Hello, friends. Are you having a nice time at Build? That was lame. It's 2 o'clock. This is apparently a little early for developers to wake up. I apologize that we got you up at the crack of noon.
We give them .NET for Linux. We give them Visual Studio Code, and that's the applause.
What's that about,
That's
folks?
it?
I know that the people who are watching on the web are more excited than you all, but that's fine. We don't need your pity applause. That's how Scott Hunter, my boss, and myself, Scott Hanselman, that's how we roll. So later on, when we give you our dog eyes and say we're sad because you didn't applaud, we don't want your pity applause. We only want it when it comes from the heart. Not like, no, please, stop. Stop. What are you? Don't embarrass yourself. Oh, my God. What is wrong with you? All right. I am Scott Hanselman. This is my boss, Scott Hunter. We are the lesser Scots.
Notice we're not wearing a red shirt.
He's actually wearing a red shirt. He's red-green colorblind. He has no idea that he's wearing a red shirt. And we also have Tiny Scott Goo, who we brought to watch over us. So in Goo we trust. So we're going to talk about Azure App Service architecture, and we're really happy that you all came to hear about this with us. Now, I want to make sure, actually, why don't you go switch and just show our little disclaimer there, that you understand that what you're seeing here today.
Switch.
Oh, yeah, by the way, where are we at? We're here? Let's.
Which one?
8. Sorry, sir. OK, what you are seeing here are preview bits. And we are not saying that just because we're afraid it's going to break. We're saying that because it's literally preview bits. We want to show you folks what is being built and how it's being built. And we're going to go a little bit slower because you know how they do these things in the keynote. They give me 15 minutes, and then right before I get on stage, they go, love everything that you're doing. All those features are great. You've got 10 minutes. And make sure you hit the story. Now, this is our opportunity to really share with you what's going on in Azure and Azure App Service in a full 60 minutes. So we're going to kind of drop down to the low level and put it all into context. We would go a lot slower.
But to preface what you said, it is preview bits, which means if you try to replicate what we're showing today, it might blow up on your computer.
It's
the portal
possible.
might blow up.
This is all live. We're not faking anything. Nothing here is fake. Nothing in the keynote was faked. But I'm really happy that it worked great.
It's preview.
All right. So that said, let's talk about it. And then make sure, of course, that you find a use for that QR code. And
I'm just laughing.
You having fun with
slides.
that clicker?
That's clicking now.
You want to just keep clicking around? What was that one that you just skipped? I needed that slide.
That was the evaluation slide, which is right after the intro slide.
That was the slide?
Because we're going to evaluate. We're done.
This is so professional. OK. In Azure today, there was Azure Websites. That's where you see like Git deployment, the Kudu service, Kudu. You may have seen that. That's the thing that manages Git deployment. Azure Websites is scalable, elastic websites where you don't have to think about the underlying virtual machine. That exists today. We love that today.
PaaS situation, everything's managed for you. Just put your app up there, and we manage everything for you.
PaaS, Platform as a Service. Mobile services, letting you have access to RESTful APIs, talk to things like Xamarin, talk to native apps, talk to Windows Store apps. That exists today. That's great. BizTalk services, reliable orchestration of business processes. That exists today. What Azure App Service is a collection of things that you already know how to use today, plus a couple of new things. And that is then dotted line around it. That is App Service. And we're going to talk about the new stuff primarily.
The funny thing about what you just said is those things don't exist anymore.
They physically exist, though. Like
yes.
web apps are web apps.
They're just new features, though.
Oh, OK, I got you.
So if you look for those, mobile service is now mobile app.
Website is web app. Right. So there are all of these things into an integrated offering. And what's nice about it, too, is that the pricing is pretty much the same as before. These things are running in a very specific way, and we're going to talk about the details.
It's actually cheaper than it was before. So we took all those features, Azure Websites, Azure Mobile Service, BizTalk services, merged them into one feature under one price, and added a few more things as well.
Right. And so if you already have a website, you now have a web app, and you can do all of these things and add to your applications that you already have today. And the interesting bits that we're going to talk about primarily are API apps and logic apps. And API apps lets you connect to all these different things. There are third-party apps. There are first-party apps. There are apps that we create. There's Twitter connectors and Dynamics connectors and Salesforce and Office 365, as well as whatever you've come up with, and the ability for you to, in the future, very soon, put those in a marketplace.
And that's because we know that people are building apps that talk to SaaS services today. We want to make it very easy for you to take the existing apps you have today and start connecting them to SaaS services.
Right.
And that's a feature of the platform.
So let's get through this and get into some interesting stuff, because we want to make sure that you understand the pitch, and then we'll show you the details. So web apps, these are the web apps you understand. You may in the past have thought that web apps just run Node and .NET. They also now run Java, they run PHP, and they run Python. And there's also a new thing called the HTTP Platform Connector. We've got, I got F# and Suave running a couple of days ago. We've got Go running. You can pretty much do whatever you want. And the nice thing is that it's an underlying hidden virtual machine. So it's platform as a service. I don't have to think about scale, just handle it. Web jobs, continuous integration, all those features exist and are getting better.
And as we talk about app service today, each of these capabilities works for each of the types that we're going to talk about in app service. So whether you're building an API app, a logic app, a mobile app, all these same capabilities are sitting behind the scenes running these things.
Right. Now, when we talk about platform as a service, we stress how important it is that you don't have to worry about the underlying virtual machine. But as with all magic layers of abstraction, if you know one layer below, you are more powerful. So while you can choose to pretend that there isn't an actual machine running under there, there is. And we're going to show you why that's important and why that can make you actually a better developer. Now, mobile apps, we've used before. We've seen those, some great demos from Josh Twist. We've got the capabilities of web jobs running for mobile apps, auto load balance, auto scale, all of the disaster recovery and geographic scale for mobile apps all exists.
Basically, all those features that we just showed for web apps
all
now
come to mobile apps.
Come to mobile apps.
Yes. So there isn't that question like what's one for and what's the other for. You get the features in all of them.
And if anybody played with mobile apps before, you might have had this question like, do I build a web app and put APIs in it? Do I build a mobile app? What do I choose? Another goal of app service is to say, now you don't have to worry about it. If you start with a web app and you want to add the mobile capabilities, that now is just going and adding some things to your existing web app to convert it to a mobile app. And so that's a big premise of this as well, is you don't have to have this choice. And if you make the wrong one, you feel like you're stuck now. Now you just start with web, and you can always move to mobile. You can always move to API.
Now, web jobs exists in web apps and in mobile apps. And people did some real, go ahead and switch to the next slide. People did some basic scheduling of jobs in the background. Like my blood sugar automatic thing is actually running in a web app. So I'm pulling that information and publishing it off into Node. But that's not really an automated business process. That's just a thing that runs as a reliable job in the background. What Logic Apps does is it takes those connectors and the ability to talk to APIs and puts it into a reliable, orchestratable workflow, a reliable business workflow that can scale the same way your other apps scale. And that's what I showed when I showed that visual designer. We're going to show the internals at that and what we can do with that and why that's important. And your web apps get that now. Your mobile apps can do this. You can make Logic Apps now.
And you can do some pretty cool stuff with Logic Apps. I mean, a great way to think of Logic Apps is, hey, I've got some data in a database, and when new data is put in, I want to run an action that goes and grabs that data, sticks it somewhere else, and we'll show some of these flows. But that's the idea, is you can build these workflows. It's actually a workflow.
It is a workflow in the cloud. And the thing that's so important about Logic Apps is that don't look at those or see people talking about Logic Apps and think that, oh, they're trying to keep me from writing code. We want you to write code with the single responsibility principle and little services that do one specific thing and do it well. And then we're going to give you tools to go and put them together into recipes that are going to be more interesting.
We should also mention a lot of BizTalk capabilities are back behind this.
We actually have a slide on that, in fact. We'll talk about that in just a moment. So these API apps, there are dozens and dozens of built-in ones, and I'm going to show Twitter and Dropbox and Twilio and all that kind of stuff. But we want you all to make these as well and put them in. The great thing also about API apps is that it's using open standards. The example we're going to show you is using a great open source library called Swashbuckle. And we're going to talk about Swagger and what that means, what the metadata means. Okay, there's piles of them. The next slide just shows a whole list, and there's actually a lot more than this.
We have more than this. This was a list that we did a few weeks ago, so there's more than this
Several
now.
dozen, as I recall.
There's like 50 plus now, yeah.
Okay, so that all wrapped up on the next slide is app service, okay? So let's look at it this way. Now, you see that picture, that window pane where it's like, here's just 4 boxes. And this is a tough thing about explaining architecture. Hey, here's 4 boxes. Doesn't that make total sense? So I rearranged that with his permission. And by the way, have you seen this slide? And I put API apps underneath it. Now this is confusing because there's the physical reality that we'll explain to you about how these things live. But the idea is that everything is an API that can be consumed from everywhere. And when we start talking about authorization and authentication, then things get really, really exciting. But this is a more kind of an architect's view of what's going on. So if we took an example, like a car dealership or something like that, go ahead and hit the next slide for me. And we expand that out. This is similar to the slide you saw in the keynote briefly. You might have some websites, multiple websites. Some are internal, some are external. Some may be using hybrid connections. Some may be using VPN. Doesn't matter. You've got some mobile apps, Windows Store, Windows Phone, iPad, whatever. They're going to talk to a series of API apps and communicate with those. And then business processes that maybe change often or need to be really reliable, the kinds of things you would do in BizTalk will live as logic apps. So maybe you can speak to what's changed with BizTalk on that next slide.
Well, actually, I think it's changed, but I think this is the next evolution of BizTalk.
Evolving, rather.
We're evolving BizTalk. So this is, if you're a BizTalk today, those products will continue to exist just like they do today. We'd already moved BizTalk to the cloud as part of BizTalk services. And then as part of Azure App Services, we're taking all those BizTalk services features that we added, that we've already moved to the cloud, and now making them even more accessible to people using logic apps. And so that's one of the real goals, is to make some of those BizTalk features accessible to more and more people. And we're going to start off and show that in just a second, actually. So this kind of talks about API apps, which is the underpinning of everything that we have here. And so there's a couple of things that we thought of today. If you're building an API, there's a lot of things like, how do you control who can call your API? What's the access control? And so we'll show today that API apps make that very simple to do. Whether you just want to make it public or private, whether you want to put it behind Active Directory, Twitter, Microsoft, Facebook, or other things, you can do that. Another thing is, if you're building an API, you might want a single sign-on, where I sign on one time to Active Directory, and then as I call other APIs, I want that to flow through to those APIs, because I might sign into Active Directory and then have an API app that talks to Office 365 and not have to do that auth flow. And so we'll do that auth flow for you. Another thing is metadata. So one of the things that makes an API app, it's just an API. So you don't have to actually do anything special or use any special libraries. You can just take any API that you have today, whether it be .NET, Node, PHP, Python, Java, and all you have to do is give us some metadata. And with that metadata, we can actually light up so you can easily call it from the web apps, the logic apps, and everything else. And we're going to go into some details on that.
So let's do that. Let's get down into the actual nitty-gritty of it. So let's switch over to 8. OK. So I'm sitting here on File New Project, and I can pick this new option, Azure API App. OK, I could do that. But if you don't mind, I'm going to not do that.
You don't have to do that. So
I want to show an existing web API.
So the API app template we have there is just if you want to start off and have everything pre-done for you. But as we were saying earlier, you can take any existing API you have and convert it into an API app. And we're going to go through that logic and workflow right now.
So let's say that I've got an existing web API. And I'm just going to change this one here. This is, nonsense, values controller. I'll make it contacts. And we'll have it return a contact that is a thing that doesn't exist yet. And we'll go and make a new contact. And I'm actually going to steal from an existing app to save time, because I don't think people believe I can type. Like, I don't know. Never actually seen him type. And here we've got a get and a get by ID. What I'm going to do, I like to do this for test applications. There's this really great open source application that's called AutoPoco, automatically and make a plain old CLR object. And AutoPoco will go and generate basically objects for me. So I'm going to grab that from NuGet and bring that down. And then I'm going to borrow this whole chunk here.
So the main thing that Scott's using AutoPoco for is he wants to have some data. He doesn't have a
Give
database
you
at this
some
point in
data that's
time.
not nonsense.
And so he wants to randomly create like 50 customers that he can actually call and use of this. And so
here,
this,
right. So here we're just going to say, for the purposes of this demo, go and make me 50 people, and then basically mix up their names. Give me his first name this and last name that, and randomize. So this is just giving me a nice list. It's like a fake database. It's good for testing. It's a really great little library. And then down here in Git, we're going to return contact instead. And then I'm going to go ahead and just return that user's list. Okay? So if I go and do that, let's see if that works. Contacts, I think. Okay.
there you go.
So there is XML, and if I put in except JSON, that would come back as JSON. So I just brought you some real data. That is a cheap web service. Okay. But with these kinds of things, and if I was going to do this as JSON, there's no schema here, right? If we remember, there was the time of WSDL and the time of XML schema, and there were good things and bad things about that. I lived through those times. I built a lot of great stuff with those times. But now we're going more towards a more dynamic model and a more RESTful model, and things have changed. But there is a thing called Swagger that I can bring into my application. Swagger is kind of like WSDL for curly braces.
It is.
If that's not an unreasonable thing to say. And there is another open source project that we use and appreciate that's called Swashbuckle. And I'm just going to go and add that. And Swashbuckle now, I'm going to go ahead and add that and then run my app again. And
It's going to describe the API that you wrote.
Exactly. I'm going to go and hit /swagger. And I'm going to get this lovely app. And look, it shows that API. Okay? Go ahead and click around there for me while I paste. So there's the Git. Click on the Git. There's the model of that. So this is describing the schema of this RESTful web service. And this is not a Microsoft thing. This is just an internet thing. And you may have seen that kind of thinking in a lot of the stuff that Microsoft's doing. If the internet did something great, then we'll adopt that really great thing, rather than trying to invent something. So this is a model that allows you to do that. And now you go ahead and hit try it out. And see, he's got response content type application JSON. So it's a little tester as well, which is quite nice. You can create Node apps, Go apps, whatever. And if they return Swagger, then they have a described metadata endpoint. And then we can go and do stuff with that.
Yeah, this actually gives you, as Scott was saying, it gives you the ability to actually try your APIs out live.
Yeah, and there's the response body. And notice that response body came back as JSON because the request said, I don't want XML, I want JSON. I could have removed the XML, as with any ASP.NET Web API, by removing that formatter. I could have it return other things as well. Okay? So you theoretically could go and add Swagger.
Why don't you go to the URI and show the actual Swagger that comes back?
Oh, yeah, that's a good point. Thank you, sir. That was a very managerial thing for you to do.
Thank you.
Yeah, that's nicely done. So he says, why don't you just show the actual stuff? So this is saying that there's an operation, and this operation is called account.whatever. Close that one up and show me the context, actually. That's the accounts. This web API has one for user management as well. Account logout, blah, 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 change password, set password, yada, yada, yada. I've got JSON view here to make it clear.
There we go.
Contacts. So there's contacts get. Notice that it says, well, I also produce XML, and I have these responses. It provides a lot of information about that, maybe even more semantic meaning than WSDL did. So rather than looking at this like I did, which was, oh, we did WSDL all over again. Wow, OK. I think about this as a refinement of the stuff that worked in WSDL and the stuff that didn't work, and bringing it into a model where there's a lot of really great services out there.
Look at there. There's the definition of the contact you just had. It's got a first name, a last name, a birthday, height, showing the types.
Right. So that right there is really significant. because there's always this, this impedance mismatch between the serialization and deserialization of these kinds of objects. I spent a lot of time in the early 2000s serializing and deserializing stuff.
Well, one of the most requested features we've always had from ASP.NET Web API was how do you do the same things you could do with ASMX or WCF, which is how do I build a client that can talk to it?
Mm-hmm. So we should probably do that.
We should.
OK, let's. So.
And so the swashbuckle that Scott showed, anybody can use in any ASP.NET application today. You can basically grab that NuGet package, stick it into any existing Web API project that you have, and it will automatically generate the Swagger for you. And it will also give you that test panel where you can actually try your APIs and run them.
Now, I can go like this. You have to tell me if I'm doing this right. If I go and say add app client, would that work with my local application as well?
Yeah, it should.
So I just said add, and I can say add Azure API App Client.
It'll only work on your local client if you have the Swagger file saved to disk.
Which I will go and do. So let's watch me log in. No, I don't actually ever use this device. No, I'm really seriously true. I don't, really don't.
I think you're going to log in, Scott.
Are you sure? No, I don't think so. I refuse.
Notice you had to refuse like 6 times. It really wants you to log in.
So that's actually a bug. And no.
We don't ever have bugs.
What that is I actually am a member of 7 different individual Azure subscriptions, and I don't really feel like logging into each one individually. So then it sensed my fear with the connect. Don't like that. All right, so I'm going to take this file here, and I'm going to go and save this JSON. Superswagger.json. And then over here, I can go and point it as an app point it at an app service, and then this is a list of the API services, pardon me.
You've been busy creating APIs, man.
Well, yeah. So did I mention I was in a lot of stuff? Yeah.
We make Scott write a lot of code.
Apparently. And I'm going to go ahead and grab that one and hit OK. And this is going to go and use a thing called AutoRest. That is an open source and lovely thing that I'm going to give you more details on. And where did it end up putting that, boss? Down here?
It normally should create a folder for you. There you go.
It put it in the same with the namespace there.
Yeah, it's whatever the namespace of your
So there's
API
the
is.
contact. I'm over actually, I made a mistake because I did it in the web app.
Yep.
That was good. No one said anything, though, which makes me disappointed, frankly, in this audience and their ability to keep up. Is it more fun to watch? Is it?
So Scott
really
unfortunately
more fun to watch?
created the
I don't
API
think it
inside of
is.
his own API. So an API in an API.
I'm going to call
So now he's going to create the console
I'm
app
going to
here.
call myself Super Swagger. Oh, crap. There was a memo to tell me to stop doing that in public. Darn. Did you send that memo? So, oh, darn it. I think that the subject of the email was unprofessional. What is significant is anyone hiring? Anyone hiring?
You know Scott and I have kids when you see poop.
Yeah, we have little kids. So this is going, and this is what's great about this too, is that there's no black boxes. Okay, there's nothing hidden here. Because sometimes when you hide stuff behind a dialog box and then you don't let anyone see what's happening, you're like, whoa, what did you just do? This is generated code that's generated with an open source project that you can go and look at. You can modify the generated code, you can modify the generators, you can write your own custom generators if it makes you happy. And this is just doing a RESTful call and bringing this data back in a way that we can understand it.
This is actually the same technology we use to build the Azure SDKs. So part of our team builds the Azure SDKs, and we were hit with this problem years ago. It's like, how do you build an Azure SDK for .NET and for Java and for JavaScript and for PHP and for Python, for Ruby? We don't want to build that same SDK a million times, and so we actually, inside of Microsoft, have Swagger files that define the Azure API service, we run this exact same tool over those Swagger files to generate what we call the Azure SDK.
So think about that for a second. You know how we go and we show you the cross-platform Azure SDK, right? And the one that's written in Node. And I always point out how, and we're calling a back-end RESTful API that Azure took. Somebody, some brilliant person internally said, hey, this is cool, we should give this to the people.
Yes.
And we did, and that's useful. And that's the kind of transparency and the kind of interaction that makes me happy. And this is doing that boring code, the boilerplate code, you know? Go and set credentials if they're there and get a response and trace the response. And the, you know, the
but
stuff
it
that you have to
technically
write
brings
anyway.
add service reference back to ASP.NET Web API.
That is a great point. So it's kind of like add service reference, except the service reference is a RESTful API.
Yes.
Which is really, really nice. Now, in this instance here, as I recall, boss,
You want to create a web app 8 or whatever you called your thing.
I'm going to go and say var web application 6
because that's what you would call your API.
Web application 6, right?
You just knew it up, yep. That's your client.
And then go like that, right?
Call contacts, call get on contacts.
They're called .get.
Yep.
Yeah, and see, those are extension methods, all of it not hidden. Now this, though, needs the URL, though, doesn't it?
It does.
Because I haven't put it in Azure yet. So that's an override. So I'm going to go and say like this, can't I? Oops. Can I just go and go like that?
You can. We'll see if it blows up.
I have to say new URI or some nonsense. Yeah, here we go.
If you're creating one of these from Azure, we actually put the URI in for you automatically. So if we did a demo showing the one running in Azure, it'll actually work.
All right. So I'm going to put a breakpoint there and run that again. Oh, in the debugger.
People.
Awesome. Isn't that cool?
It gets better.
But wait, that's not all. Which part were you thinking of?
I was thinking of showing the command line.
Okay, let's do it. Let's do it. So
as we mentioned, while Scott's working on the computer, we mentioned that this is the same tool that we use to build the Azure SDKs that we're running under the covers.
We did.
And so not only can the tool generate the C# that Scott just showed, but I think we got a build this morning of this that will actually let us do Python, Java. Does it do Java?
Does it do Java? You just said it, so it must.
OK.
So we just got a build, like last night, of some stuff that's going to go up on GitHub soon. This is preview. But the intent is to make it so any language that makes you happy, you can go and generate these things. So I'm going to show you that in a second here. But I want to make the point, anything you like on the server can make these APIs, and anything you want to consume them with. So it is non-denominational.
Yeah, but as an ASP.NET guy, I think of now you can write your API in ASP.NET, and you can say, hey, you can give clients to anybody that wants to call your API. If you need PHP, if you need Python, we'll have iOS and Android in the future as well.
Which means you can package them up if it makes you happy. You don't have to make your customers run this stuff. You could generate it, make it the way you want it to look, document it, add anything that you want to document your stuff. And when they see that Swagger file, they're going to have docs. And there are other open source projects that will help you build the documentation for your web APIs and take that information and make it available to people. So you now get basically client SDKs for anything that you do.
But also, as we said before, this API, we could have written it in Node or PHP. We could generate this the same way as well.
So right here, I just showed you what's inside of that command file. It's going to call AutoRest, which is the open source tool, giving a namespace. In this case, it's a pet store. And then it's going to say that the code generator is Node. In this example, that code generator is actually a .NET type. And there's an autorest.json file inside of which one can express other things. So let's take a look at this real quick. And then we'll run and look at the results. See? So the code generators are extensible. None of this is locked down. Additionally, the modelers are as well. So that brings up some interesting things for the future. So let's look at Java. Okay? And then I'm going to use code. And let's take a look at generated, C#, Java, and there we go. And then within this, you've got a client app, and then in some of the instances, there are dependencies. So for example, you can see that this is bringing in Microsoft Azure filterable service. So you can have things like, you know, paging and get by this and get by that. Every instance is different. Every implementation is custom. So for example, if I use the auto rest node, this is really important. See, it says generated code requires this runtime npm package. So then I would include that into my packages JSON and then go and run npm install, and then that's going to support that. And the code for node looks more like this. There's your, you know, your boilerplate, kind of boring pipeline type stuff. And then there's a cat, pets, and it does all that stuff. And it's doing it in really nice, clean, idiomatic, in this case, JavaScript, idiomatic, whatever makes you happy.
Yeah, we try to make it look right for the language you're using. So.
Right, and that is the intent in every instance. So they were kind enough to give us this in Java, in C#, and then also, this was when they weren't sure if they were going to make it out, but Python. And the thing that I'm also happy about, just as a plug for the tool that I'm very excited about, is in code here, notice that I'm running around inside of all of these SDKs, and I'm getting the nice highlighting and good stuff that I would expect to see, especially within the Java one.
Yeah, some of the many languages supported by code.
Yeah, it's pretty ridiculous. Like, it's not just a, you know, it's got cool stuff. Okay, that's a whole other talk. Then I could go and make those calls. So this is just showing you what a web API that returns Swagger is. But this isn't at this point, at this moment, this actually isn't an Azure API app.
Right.
Because metadata matters. And there's a piece of missing metadata here.
There's no way to tell Azure what your metadata is. That's
right.
the problem.
So I'm going to click Azure API App SDK. And it's going to grab a couple of NuGet packages. And here is what I want to show you. And this is important because I want you to understand that there are no more black boxes anymore. Okay? Two things just appeared. API app.json. It's a manifest for the app itself. And then the API app config Azure resource in the deployment template. Go ahead and open up that API app JSON for me. And then zoom out. So that is
all
not
the way to hell
button
and
for
back.
zooming out. So adorable when managers try to code. So this API app.
That's not even coding. That's like using your like weird keyboard.
You can Dvorak? What's your problem, man? This API app is telling Azure itself where that API definition is. Because there's nothing that says that it has to be /Swagger. That's a convention, but certainly if this were another app, an existing app, or an app that I was adding stuff to, it might be somewhere else. But also information like versioning. That's important as well.
Yeah, the versioning stuff's important because the API apps that we generate that run inside of Azure actually are NuGet packages. So we take your API and we put it into a NuGet package that we then upload to Azure. And there's a couple of cool reasons for doing this. By putting it into a package, let's say Scott builds a geolocation API, and he wants to share the geolocation API with other customers inside of Azure. We are going to have a NuGet-style gallery that you can go to, and you'll be able to find all these APIs, just like you can find NuGets to build applications in WinForms or WPF or ASP.NET today. Now, if you're building a client app that wants to talk to an API, you'll be able to go find in this NuGet gallery of APIs, the APIs that you want to use. And if you click one of them, we'll just automatically install it into Azure for you. So it will actually be installed into your subscription, and it will be running for you.
Let's dig into that right there, because I think that very point is subtle but crucial. When I first heard about API apps, I was like, okay, so I'll make an API, and then I have to host it and think about it. Like, I don't want to be a hoster. I don't want to be I like software as a service, but I just don't want to be the one doing the servicing. I would like to give it to you and have you host it in your own thing. Remember how we said that web sites became web apps. And web apps run inside of your hosting plan. Your hosting plan is the hidden virtual machine underneath that manages your stuff. What he's saying is when I say I'm going to get Scott's geolocation API, an instance of that is created and brought into my world, and I own it, and I control it, and I decide when it gets updated.
You manage it.
I manage how much memory it gets and what the pricing is like.
If you want to scale it, you scale it yourself using the same features of web apps.
And if a new version comes out, I decide whether or not I want to auto-update for minor versions or take another one.
We'll show that in the portal. Another feature, because it's a NuGet package, is we have the ability to say my app can automatically start taking advantage of a new version. So let's say a new version is published. Scott publishes a new version of his geolocation API.
Mm-hmm.
If my application is configured to take auto updates, what will happen, any minor updates will automatically go live in my production without me touching anything. I don't have to go and manage all these things, which means as an organization, you can publish API apps
right.
Across all the apps you're running inside of your organization, and not have to have IT go sit there and go push it to this and push it to that and push it to this. We will do all the heavy lifting for you.
So while he unlocks that machine, you can see that I've got a Slack connector and a Dropbox connector. I've also got Twitter connectors. These are API apps that are running inside of my hosting plan. This is not Microsoft will handle Dropbox stuff for you.
No.
This is you have an instance of this API app, and that's really nice. So if I go and click on the Slack connector, I've got to manage it and monitor it and deal with it like any other application within my system. And notice this, I click on API definition, and I can see that there's some swagger, and Azure knows about that. So now I can post messages into Slack channels, as an example, okay? So then, if we look at one that I published earlier, I'm actually going to switch over to Azure Cards, if that's okay with you.
Actually, before we jump into this, why don't we go back to VS real quick and show how we would publish those APIs that we just built.
That's a good point. It's going
We
to require...
never close that scenario all the way down.
It's going to require hitting cancel a lot, though.
So, yes, it will. So after Scott had built this API, let's say he wanted to publish it up as an API app.
Yep.
When he right-clicks on the project and clicks Publish, there's a new thing that shows up in preview format that he clicked through too fast that we never saw.
I get it.
Now he's going to cancel 7 times.
Sorry. I apologize. I need to just, the thing is, it would actually be faster if I just signed in.
So you'll notice that there's a new feature here, Microsoft Azure API Apps shows up here.
Right. And then I would go and either pick from an existing one or go and create a new one from here. Okay? And you remember how you get 10 free web, same thing applies.
Yeah.
So you can go and make these for free and have fun and do the same things with either your trial or your free subscription benefits as before. But the point that he's making is that you publish these and they are treated the same, except if they are API apps proper, they know other things. They know things like their API definition. So this thing called Azure Cards that I wanted to bring up is an interesting project. And I believe I've got that running up here right now. So I'll show you what it is. Azure Cards. Do I have Azure Cards? I apologize. Let's grab that. Here we go. And this is, Brady Gaster made this. This is a card shuffler. So I can say new deck. It makes a call back to a back end, shuffles the deck, and then deals out the cards. And then you can see the Azure deck of cards, okay? So there's Swagger for this, there's the back-end service for this, and in this case, this is an Angular app that's making the call back, okay? So this is a static website API, and it has Swagger for what things you can do on the deck. Make a new deck, shuffle it, deal it, how many cards are in the deck, stuff like that, okay? If I go into the Azure portal, we can see that it knows about that stuff.
Yep.
Okay. So if we switch back over here, Brady has been so kind as to make a console client. Now, you've seen the console client before. Less interesting. Let's introduce a new concept here. It's easy to make a little contact application that I just made, right? And then say, hey, look, I called it, get, yay. But when things get hard is when it's like, okay, now OAuth it to Twitter and manage all of that token stuff and then put in Facebook. And then suddenly my 5-line sample application becomes 805 lines, where 800 lines of it manage the authentication and 5 lines do the actual work.
Has anybody written OAuth code in the room? Bunch of folks.
Good fun, isn't it?
So who wants to write, when you write a card app, who wants to write the calls to the callback URIs and to process them and all this kind of stuff?
The authentication code is a concern that is orthogonal to the app itself. It doesn't matter that the card app does cards or the contact app does contacts. Those things should be handled for you. So there's a gateway, also owned by you. This is an app. This is not, again, an Azure thing. This is a you thing. Gateway is automatically made for you, and it sits in front of that application. So I just called that card app, and it just worked because it was public. It was unauthenticated. But I can go in, make a Twitter account. I did this already, a dev account. Add in my secret keys under identity here within the gateway. And then set up Twitter authentication or Facebook or Microsoft or whatever for this particular machine. And then call that as an authenticated service. So now
I wanted to show that as well.
I can go in here. Remember we talked about auto updates? I can go like this. There's anonymous, there's authenticated, but there's also internal, which is it's public amongst people who are inside of your Azure resource group, so that your APIs can call each other, but it's not accessible via the outside, which is actually more useful than you would think. Because if you were going to use this in a workflow inside of a Logic app, you don't want to think about those things.
Auto update is covered here as well. So you can see the auto update settings can be off, can be on, it can be inherited by its parent.
Yeah, so this is really, really significant. So I can go back over here to my application that was going and calling these, and this part here, create cards, make a new deck of cards. That's those 2 lines of code. Now this is a fun hack, and we did it as a console app, not to say this is a best practice, but just to take the concept of a console app and now do it authed, which I think is too insane to not do. So we run the console app, and then it prompts me to authenticate with Twitter, which I think is epic, just on principle. And then redirects me, and then I get the deck ID of that cards. Isn't that cool? So,
yeah, that's cool.
see, Brady is going to feel really good because at 3 in the morning, I was like, we have to authenticate against Twitter in the console app. Like, who would do that? That's insane. But it makes the point, doesn't it? So then our good friend Brady goes and does the same thing for a store app. So you go like this, and you've seen this before, right? Connecting to a service. Now we have a much better application, and I hit deal, and he's going to go and bring those down, and now that works. So the authentication has nothing to do with the API. So now think about all the APIs that you have as your company that are useful, that are interesting. Add a little swagger, put them up into Azure App Service, and then start taking those cross-cutting concerns and abstracting them away.
Generate clients that can be used from mobile, web, console.
It's hot. So let's shift gears a little bit.
We haven't shown Logic yet.
And go to Logic Apps, shall we? Good call. So we saw this before, this idea of this surface here, okay? And it says Start Logic. And on the right-hand side here, it says, this is really important, API apps in this resource group. This is my stuff. This isn't all of the applications that are available. That's a whole other thing.
Yeah, do we have the resource group on the start board?
Do I have the resource group on the start board? I don't know. I do know.
Go browse.
You can make me look for it?
Show your
I have a lot of stuff.
Show your resource groups, not just browse resource groups.
Okay, browse resource groups.
So when you create API apps and you create Logic apps, we ask you to put them in a resource group. And a resource group is technically a container. And the reason we want you to put them in a resource group is it means you can actually manage them all as one instance. So let's say I've got a web app that calls 5 API apps and a Logic app there as well. You reference all these things together in what we call the resource group, and the benefit there is if you wanted to go delete the thing, you delete the resource group, and all the stuff goes away.
So mine happens to be, this is a good thing that he brought up, because mine's sitting in Car Dealer Logic. It has 25 total resources. I see 11 API apps, the gateway, the web app. And then yesterday, I started to feel it was getting a little sluggish. because I've got 11 different APIs there, and I got 25 different things going on. So I looked at the memory usage, and it said 85%. This is the great thing about the cloud. You want the cloud to run hot, because you want to save money. Because if it's running at 10%, then it's not really doing any work. But 85% was a little tight for me, and I just went and changed it from small to medium. So it'd be a little bit nicer, and then I'll go and clean up and remove some of the apps that I don't want.
Right.
I control that. So that's the example where I choose to live at a platform as a service world. I think about things that way, but I'm not ignorant to the fact that there is, in fact, a virtual machine that I control.
It's also the benefits of API apps, mobile apps, web apps, all running under the same container, which you can basically drag sliders up and down to scale. You can auto-scale. All these features are right there and built in.
So I clicked on the API apps in my resource group. These are the ones that are connected, including my web API, and just to make the point, a node sample as well. That is a valid and legitimate API app, as well as things like Slack connector and stuff like that, and Twitter, okay?
Jump back to Logic.
So I can actually click on here and go back to Logic. Oops, where is my Logic app? Create. No, this one. The Azure portal is starting to grow on me because it's like a whole operating system in HTML. And let's take a look here. Actually, you know, I have a better one I'd like to use.
Should we just build one from scratch to start with?
I don't want to build one from scratch, sir. I'm going off script. I want to use this one.
You're afraid to build one.
No. I have this one here, which is awesome. This one here has a recurrence that then searches for tweets with the name Hanselman, which is probably a dangerous thing to do. Let's say build win. What do I do here? Oh, he's angry at me. Oh, notice that it says authorize this action. That's where I told it the Twitter that was allowed to be used. Then Dropbox connector here is taking the data that flows from Twitter and taking the body of those tweets. And then there's a language you can use.
So once an hour,
once an
you
hour,
call a Twitter API.
Go to Twitter. I could do it every 5 minutes or whatever.
Whatever you want to do.
Oh, wow, seconds? That would be insane. And then there's a little language here. And this API is going to get better. The Azure portal actually updates a lot.
Well, let's talk about these things like body array, text, tweet text, retweet count, tweeted by.
That's out of the Swagger.
That's out of the Swagger. So the reason that the Swagger is important is when you start building designers like this to actually consume the API apps, that metadata is what's driving all of this and letting Hanselman.
Moreover, if I click on that ... I get the entire thing, including in this case tweet ID, which I see is specifically like that, tweet ID. Okay. Then I'm going to go and drop those things into Dropbox. So I'm going to actually hit save on this one here, come back out and enable this. And I don't want to wait an hour, so I'm going to run it now. And then I can click on each individual run, see what's running and what's not within that entire orchestrated workflow. Oh, look. Ooh.
So we took your tweets and we saved them to Dropbox.
And now they are here. That's the tweet ID. I just used the tweet ID as the file. Isn't that cool? Hopefully it's not bad. Drinking a Newport Storm. That's not good. There you go. There's a retweet. So it brought that in. So then I could say, well, don't save retweets or go to. So you might look at this and say, well, this is similar to something like, you know, if this, then that, or something like that. But
let's go to the marketplace.
Let's look at the marketplace, because it's quite a bit more.
Now that we're talking about building these logic apps and the API apps that you can consume to do this, we already have this gallery we talked about earlier before of like 50 of these things that we've pre-built. A lot of these came from the BizTalk team, so there's a lot of BizTalk connectors in here as well. But you'll see connectors to a lot of popular SaaS services, a lot of Microsoft services. Here's some BizTalk stuff.
You know, and this brings up another interesting point. Layers of abstraction, how much you choose to hide. You can be thinking about this at the high-level business process, like in the demo where I get an order and I text someone with Twilio. You can do search Twitter and put it in Dropbox. And that, again, might remind you of things like Zapier. But this is running on my machines. I like to say it's on my hardware, even though I'm borrowing it from Azure.
Other examples we've done is we've actually looked at a SQL database and moved data into something like Dynamics or Salesforce.
Yep.
So anytime a new record's added, a new customer gets added somewhere, we go and stick that customer into our CRM.
We've seen some really interesting things where people have taken old legacy apps, really old ones, that they're afraid to touch. Let's say you've got a classic ASP app that writes to a SQL Server database, but you've all switched over to Salesforce. But everyone likes that app, it works just fine, they don't want to touch it. You can go and have a job that runs and pulls that out and then sticks it into the new CRM. You can attach things together. Now, layers of abstraction. Dropbox, Slack, Twitter, FTP, POP, HTTP, SFTP. So you can choose the layer at which you want to go. So let's do a really low-level one. Is that okay with you? Let's do HTTP.
So the HTTP one's interesting because in that case, he's not going to have the metadata and stuff that he's doing. He's going to go raw. He's like, hey, there's no API app here, so I'm just going to call out right to a RESTful API that I already know. And he'll have to be more direct because he doesn't get that swagger help. Another cool concept to think about when you saw that in Marketplace. We're in preview today, so we don't have this feature yet, but another feature that's coming online pretty soon is you might be saying, hey, I want to go create my own API apps, but I don't want them to show up in the Azure Marketplace. That would be crazy. I don't want the world to see them. We also will have the ability to have a marketplace for your organization. So when you build your own API apps and you upload them, you'll be able to upload them to a place where anybody in your org can come and find them in a marketplace just like that and choose and pick, but it's just yours. And so we're going to make it really easy for organizations to create their own APIs, host them, and share them inside their own groups.
So here, I'm going to do an HTTP GET to a URI that has my blood sugar. And I can choose authentication or what I want to do and all those kinds of stuff. That is a valid URI. I know that for a fact. No, it's not at all.
No, it's not.
Thank you for telling me that. And you lied to me. See, because we don't have the Swagger data, I get access to the
he now
headers
has to
and the
hand
body.
type everything because there's no
But
metadata.
I could even go and add another one, and then go and either go and post this to another URI. And I like this place called RunScope. And RunScope is a really cool. This is not a Microsoft thing. It's somebody else. They are a fun, basically there used to be a thing called SoapScope back in the day. It's a proxy that sits in between you and your web service and lets you have buckets for debugging. So I have a special magic bucket. And I can go and take that magic bucket and stick that here. There's also another one called request bin that is really nice. And I can decide where the body's going to come from, and I can pick that body from here. So you're pulling that from the output of the previous item. Okay. Here we go. So I'm going to get from here and post to there. Save that. And let's see if it works. That'd be kind of cool if it worked.
There you go.
Oh, did it already do it?
Yeah.
Ooh. I'm not surprised at all. My blood sugar is 69. No, just kidding. I'm fine.
I've got sugar.
Oh, yeah. Quick, pour a Diet Pepsi on me. That would do nothing.
I was going to say, you need a non-diet Pepsi.
Find me a regular Pepsi. No, so here we've thrown that through. So when I was doing debugging and stuff of the Twitter and Dropbox, I just popped in a request bin or a RunScope, and I figured those things out and get to watch them. Now, that authentication thing. Talk to me about how authentication would flow through something like this as I started plugging real API apps in.
What part of it you want to talk about? You want to talk about if you put like Twitter up there and you have to authorize Twitter?
Yeah, so if we go and look at a more interesting or complicated API, logic app rather, let's take a look at one of those. And a logic app that has a lot of different bits of authorization, you don't want to have to think about, like, I logged the user in, and now I want to flow off through an entire call, a series of calls.
Well, especially in the logic app, that's where you really don't have any, where would you put your OAuth endpoints and all this kind of stuff.
So what you do is you've got, each instance is authenticated. So if I am sitting in an app right like this one, we've got SQL and Salesforce and Twilio, and I dropped in Twitter to do something at the end. Twitter says connecting to API app, and then depending on whether I've authenticated this one again or not, it will say authorize. So I say individually authorize that instance to run on my behalf. And just like any other app in Twitter or any of the other things that you might OAuth against, you can revoke that potentially. Now you can set that at the logic app level or at the API app itself.
Or what I could have done, Scott could have also gone and created the Twitter connector manually from the plus at the very bottom or from the marketplace. And then if he drills into the properties of the Twitter, it will actually have places where your API keys and your authorization key goes to do that as well. So you might do that in the case of you might want to have a Twitter connector sitting out there, one that's on behalf of you, and you might want to have another one that's on behalf of your company. And what's even cooler is you can actually create both of those. And with some of the features inside of Azure, we have RBAC, which is role-based access. I could basically say, Scott's allowed to tweet on behalf of the company, and everybody else is not allowed to tweet on the behalf of the company.
Now, and then one thing that I want to add, because this is just a thing that I'm on right now that I really think is important, is there's a lot of push towards raising the layers of abstraction and making it so we're up here floating in this logic app world. But the reality is, if something doesn't work out, you want to figure it out, okay? So in this example here, we actually have a fortunate thing, an error occurred. And here it's saying, can't fetch this Swagger API, so that one individual logic app has told me that there's a problem. Maybe that's disabled, or maybe I haven't figured that out. Because these applications are still our apps. They are web apps underneath.
They're all web apps.
Okay? I can come in here, and I can look at, well, who's hosting that particular thing? Here, see, by the way, I told you I switched it to medium. Who's hosting that? And now, look at this. I can go in and see, are there any errors? What's going on? These are deployed with Git or whatever. I could even, I love this, by the way, and this just really makes the point about high level versus low level. I'm inside the Azure portal. Something's gone wrong. Hey, I don't know. It didn't work. Delete it and put it back again. No. What happened? Let's get in there. Now I'm at a tiny fake DOS prompt in the cloud. That's awesome. Thank you. Let's applaud. Let's yell for the tiny fake DOS prompt. So I can even click on processes in this API app. Take a look at this. See the Node app. Click on the Node app. From that, how much memory is it using? Is there a problem with the process? So when we're up, what modules does it have loaded in memory? For crying out loud. What version is it? People show you platform as a service solutions, and they say, yeah, you just deploy it and it works. But when it doesn't, you go and you figure it out. And that's what I think is so powerful about what they're doing here, because they didn't go and create app service and then hide all the complexity. They abstracted it away, but I've got a great DevOps dashboard with all sorts of detail if I want to look at it from a business person's perspective. How many instances, how hard are they working, da-da-da-da-da. But now I can go all the way down into a specific thing and say, oh, that's the wrong version of that DLL.
We're not going to go into it, but it goes even further than that. If you're in Visual Studio, you can actually attach the remote debugger to the same running instance in the cloud as well. So nothing prevents you from going to VS. It's in the Server Explorer.
Yeah.
And API Apps will show up as a first-class citizen in the Server Explorer.
Log in? You know it is.
It's going to ask you to log in.
All right. You talk about that while I log in for the first time.
And inside the Server Explorer, we're going to show you all of your mobile apps, all of your web apps, all of your API apps. And you can drill in and actually look at the logs. If you want to see streaming logs from any of these API apps, logic apps, web apps that are running in the cloud, you can do it right from inside of Visual Studio. You can also right-click on these things as well, and there'll be an attached debugger, and you can live debug in the cloud. It takes about 30 seconds to boot up the very first time as we install the remote debugger in your PaaS environment. Yeah. But once it's done, you can just do it. Let's find one.
See, streaming logs, attached debugger. So that streaming log stuff and that DOS prompt stuff I saw, you can see it in here. And what makes me happy about this, actually, funny story, is not only can I do it in the portal, not only can I do it in Visual Studio, right? But if I want to go out to the command line and type Azure site log tail foo, and then I'm using the cross-platform command line, and I can actually go and debug these things as well. Right, and I did that recently, seeing some logs as it was being deployed.
Well, you might do this if you're using Visual Studio Code on a non-Windows device.
Absolutely. So I think that's our time.
It is.
We have been the Lesser Scots. We are really sincerely excited about Azure Application Service, and we hope that you check it out as well. Thank you very much.
Thank you.